The idea of 3D printing is around since 30 years. Over the early years, only few people had access to such systems, because it was exclusive and very expensive. Thanks to the expiration of some key patents and open source software and hardware, the 3D printing technology has been accelerated, and it is now affordable for everyone. It is said that 3D printing is an exponential technology. It is much higher impact in technology and our lives than we thought a few years ago. It is now a multi-billion-dollar industry, with an average annual growth of more than 30%, which is a very large number compared to current economical growth. In contrast to many technologies which have linear growth, the 3D printing has an exponential growth. It is also what we know as disruptive technology. This is a sort of innovation that creates new markets, new values, and eventually revolutionizes the existing markets. You may compare it with some famous examples of other disruptive technologies in the past: digital cameras, smartphones, and social media. All of these have changed our lifestyle. The 3D printing is now doing the same. 3D printing has lots of applications in various fields. Nowadays you can 3D print almost everything, from jewelry, clothes, toys and cars, to entire houses. Even human organs, such as heart, can be 3D printed. There are several 3D printing techniques, and each of them works for a number of materials. Meanwhile, we can print various polymers, metals, ceramics, electronics, composite materials, edible materials, and biological living cells. The main problem and struggle in 3D printing community is that the quality of 3D printed parts mostly depends on the expertise of the operator, rather than the quality of the 3D printer. Well, there is a simple analogy for it. If you take a taxi, you would say the same. The quality of the ride with a taxi highly depends on the driver, rather than the manufacturer of the car. The situation in 3D printing technology is that the technology is growing very rapidly, but there are not enough experts, no systematic education, and no comprehensive training or certified program available, so far. I3DL is a very strategic solution to this problem. I3DL, International 3D Printing Driving License, is the first and only comprehensive certifying program on 3D technologies, that is 3D printing, 3D scanning, 3D modeling, computer-aided engineering and related technologies in Industry 4.0. So, why I3DL? It is because I3DL is simply the language of new technology revolution. In the new technology revolution, the I3DL is just as important as an MBA certification for successful business owners, and it is as vital as speaking the language of the society you live in. We know that international certifications and driving licenses are more effective and more valuable than degrees, especially when it comes to employability of people, and real up-to-date knowledge required in industry. I3DL is a modular training and certification program. The contents of modules and sub-modules are customized to the needs of special target groups. Of course, an artist, fashion designer or a jewelry maker has different requirement in 3D printing compared to a mechanical engineer, researcher or a scientist. There are basic modules that are fundamental for everyone, and there are advanced and professional modules, which are targeted to specific topics. I3DL training and course structure is very simple and straightforward. Every module is designed to be equivalent to one ECTS, which is the European Credit Transfer System. There are in total over 30 modules, which we will discuss in details. Each module includes 20 hours of training, plus additional 5 to 10 hours of practicing self-learning, which brings it to a sum of 25 to 30 hours of workload. From these number of hours, it is usually planned that 8 hours is organized in a present form, like a workshop, seminar and project meetings. The rest is done in form of online learning, blended e-learning, practice, or project. Just to give you an idea about ECTS standard, one academic year corresponds to 60 ECTS credits that are normally equivalent to 1,500 to 1,800 hours of total workload in a year, for a full-time university student. I3DL training methods include various kinds of assignments, including readings, videos, webinars, tutorials, quizzes, Q&A sessions, discussion and several projects. I3DL also offers online courses, which is self-organized and self-paced. A prerequisite is that candidates or a local organizer have access to the required hardware such as 3D printers. I3DL is totally compatible with the concept of third-generation universities. The trainers are well experienced with these concepts, and it is well integrated in the courses. Major elements of this concept includes interactive training, practical and industrial projects, innovation and entrepreneurship, multidisciplinarity, research and development, and international recognition. I3DL program has been developed by Zamstech as a result of over 5 years of development, collaboration and partnership with tens of European and international partners. It has been successfully offered for the first time in 2015 in Europe, in English and German languages, and from early 2017 is available worldwide. Zamstech, Science, Technology and Engineering Consulting, is an accredited tech consulting firm with headquarters located in Austria, specialized in the fields of mechatronics and technical physics. Zamstech is also a member and partner of several world-class business, professional and governmental organizations. You can check the website for further details. The mission. I3DL is dedicated to raise technology awareness and technical skills standards in the academia and industries, as well as in the whole society. I3DL certification programs enable individuals and organizations to systematically assess, acquire, develop and certify their expertise in the use and further development of 3D technologies. I3DL is the world's leading 3D tech skills certification. Possible options of the I3DL certification are Basic, Core, Essential, Advanced, and Certified trainer levels. Basic level is the first one. You can simply get it by passing 2 basic modules. They are very practical choices to get started with 3D printing and learn how to operate 3D printers. This is also recommended if you want to buy a 3D printer and not sure which option you should go for. Core level requires passing 4 modules, 2 basic and 2 advanced modules. This would be an option to get started with a couple of advanced modules and get expertise in specific fields and optimize the quality of your results as you may need it in your application. Essential level requires passing 6 modules, 2 basic, 3 advanced or professional modules and 1 project module. This certification level is the highly recommended milestone, and it already opens up your way to become a 3D printing expert, use 3D printing for your career or business, or become a basic level trainer once you pass 2 didactic modules. Passing the project modules guarantees that you can practically use the knowledge in a project. Advanced level, you can reach this level after passing at least 10 modules including a project. It is a perfect path to become a multidisciplinary expert and consultant in 3D printing, and opens up the option for you toward becoming a 3D printing trainer. Certified trainer. This is your milestone to become an independent 3D printing consultant, and an accredited trainer. For this you have to pass at least 12 modules from all offered modules, plus additional 2 didactic modules for teaching techniques in the framework of third-generation university style. So you can perfectly integrate research, development, innovation, and entrepreneurship in teaching. So at the end you can train 3D printing experts who create jobs for themselves and their societies. A frequent question is how fast I can get to highest level. Well, theoretically, you can start now, and you will reach the highest level within approximately 3 to 6 months of full-time training. Of course, if you have the required resources, and if you have the willingness and motivation to reach these qualities. Exams, scoring, and evaluation criteria. Whether you attended in an online I3DL course, or an I3DL workshop organized by partner organizations, or even if you have already the required practical knowledge, then you can go through the exam to prove your expertise, and get the certification. The I3DL exam is an individual exam and evaluation of each module. You can bring the records of your relevant learning and past projects. Basic criteria and scores include theoretical, experimental, ICT and innovation. The theoretical score shows the general knowledge and understanding of methods, theories, concepts, materials and process mechanisms used in every module. The experimental score includes the practical expertise in projects, quality of items produced, and capability to troubleshooting, debugging and maintenance of the system, as well as the practical expertise in building complete 3D printing systems, robots, or other devices introduced in each module. The ICT score reflect the IT, software, and communication skills. Obviously, this includes all software and programming skills used in various modules. The innovation score shows how an individual goes beyond the state of the art and produces something new compared to everything else already available. This also indicates your deep understanding of new materials and structures, new designs and functions, new business models and value proposition, multidisciplinary and social impacts, added value in supply chain, and novelty aspects in each module. Some of advanced and professional modules have other criteria such as academic score, R&D score, and didactic score. I3DL target groups, or who should be interested in I3DL. Companies and professionals who want to adopt 3D tech and related know-how. Tech makers, jewelry makers, designers and artists. Owners of 3D printers, who want to optimize their 3D print results. Consumers who plan to purchase a 3D printer, and require acquisition and decision-making supports. Academic researchers who want to equip their lab facilities with custom parts, tools and systems. Startup entrepreneurs, and graduates who are looking for a new profession and attractive career options. Trainees and students, who have already completed computer training, and seek specialization. University professors, teachers, instructors, technology trainers, and lab technicians. And those interested in a professional certification on 3D printing. Basic modules. Module 1, it includes an introduction on 3D printing, 3D technologies, top printers in the market, comparison of hype and reality, and an overview of tools for 3D printing. Module 2. Operating a 3D printer. It includes model preparation for 3D printing, safety instructions, operating software, calibration and testing, and a 3D printing practice. I3DL Advanced Modules. Module 3, 3D Printing for Artists, Craftsmen, and Designers. It includes all must-haves for artists, basics of 3D printing for jewelry, printing clothes, 3D printing parameters, and custom patterns for 3D printing. Module 4, Innovative Materials and Filaments for 3D Printing. It includes a review on 3D printing materials and databases, concept of material selection, composite materials, optical materials, and other custom materials. Module 5, Quality Assurance, Design Rules and Optimization for 3D Printing. It includes quality assurance, quality control in 3D printing, and quality standards available for 3D printing materials and structures. Design rules, analysis, optimization, and case studies. Module 6, Building a 3D Printer. Overview of different 3D printing concepts, mechanical parts, 3D printer electronics, software for 3D printing, open source plans, workshops, and how to define your custom 3D printer. Module 7, Mechatronic System Design, Make a robot using a 3D printer. An introduction on mechatronics, basics of motion control, 3D printing of robot parts, design optimization, and workshop. Module 8, 3D Printing in Industry 4.0. Review of Industrial Revolutions, Industry 4.0 Scope, Internet of Things, Cyber-Physical Systems, and Skills Required in Industry 4.0. Module 9, Innovation and New Business Models of 3D Printing. The business models, facts, trends, forecast, risk and side effects, 3D printing value propositions, legal and IP in 3D printing, and innovation project. Module 10, CAD methods and tools for 3D printing. 3D printing CAD software, joins and connections, design of dynamic parts, custom 3D printing supports, multi-material and composites. Module 11, computer simulation, engineering, and finite element modeling for 3D printing. Review of the simulation techniques, finite element method, simulation software, multi-material simulation, process simulation, and 3D printing simulation project. Module 12, 3D printing project and practicum. This modules include several parts: preparation of a 3D printing project proposal, scientific and R&D outcome, writing a thesis, preparation of an article, and final presentation. I3DL professional modules are highly technical and practical modules designed for special target groups. Some of the modules are 3D printed optics, 3D printing for metal casting industry, 3D food printing, 4D printing and smart self-assembly, 3D printed jewelry, 3D printing for medical and dentistry applications, 3D tech for women entrepreneurs, construction 3D printing, 3D printed houses and bridges, 3D printing for agriculture and farming, 3D printing for making animations and film production, 3D printing for geology and earth sciences, and academic research and development in 3D printing. I3DL Network includes these. I3DL event hosts are the individuals or organizations that host I3DL events and take care of the local organizations. Accredited I3DL trainers are the trainers specifically accredited to run the I3DL events. Accredited I3DL centers, which organize multiple I3DL events and have the required infrastructure and trainers. Regional and country representatives are organizations which represent I3DL in multiple locations, a region or country. As a graduate of I3DL program, you have multiple paths to precede your career development. There are multiple industries that are seeking 3D tech experts, and some of these include software industries and app development, mechanical engineering, robotics and automation, material engineering, consumer electronics, architecture and interior design, and automotive industry. I3DL is also getting integrated into academic training programs. One special target group of I3DL are the university students. We are now working with university professors, school coordinators, training experts, and other decision makers, who are now integrating I3DL into their training programs. 3D printing and related technologies including Industry 4.0, robotics, automation, and smart materials, are revolutionizing the technology, art, and even the culture we are living in. This is what computer revolution did over the last decades. So in the near future, the 3D tech education and training topics, I3DL, will be a part of many science, engineering, and art curricula. Now it's time for you to get started with the 3D printing and I3DL. Get further information on www.i3dl.org.